So this is me working out the post office problem, and okay, I'm gonna start. So we're told that the post office will only accept a box for shipment if the sum of the height and girth is at most 108 inches. So you can represent that as like a box, and the girth would be just the whole roundabout. So this, and this, which would be 4 sides, and the height. So we know that 4s plus h will equal at most to 108. 108 inches squared. We have to move ahead and look for the other equation, which in this case we can easily use the volume equation to help us in this problem. So volume is equal to base times height. Base would just be the side, this s squared, so it's s times s. So we can do volume equals s squared times h. And we can use our original equation to find h. So we have h equals to 108 minus 4s. So now we can just plug this into here, and we have our equation to find the maximum, the largest acceptable box. So s squared times 108 minus 4s. We just distribute s squared, so you have 108 s squared minus 4s cubed. At this point, you could just find the zeros, which I did. So in this case, the zeros are 100. If you take out a 4, you have 27 s. Oh, and you can also take out an s squared. You have 27 minus 4s. So, oh, whoops. Let me do that again. If you take out a 4, s squared, you have 27 minus s. So that means in this case, your zeros will be 0 and s equals to 27 as well. So yeah, that would be the first part of the problem. But we are not through yet because we don't need that in this case. We don't need these critical points in this scenario. What we do need is the maximum, which we could find using the second derivative. So if you do the first derivative, I'm sorry. Yes. You do v equals to 108s squared minus 4s cubed. We do v prime, that equals to 216s minus 12s squared. Same thing, you can factor out, set it equals 0. You factor out 12s, and you get divided by 12, you get 18. So you have 12s. Maybe I shouldn't have used s. Well, anyways, you have 18s. 18 by itself equals 18 minus s. So in this case, s equals to 0 and s equals to 18. So now you can use the second derivative test to find the maximum. You know that since 0 is not a distance, you cannot use that as a critical point. So you can just get rid of 0. 0 gets out. So you can use 18 to test for the derivative for the maximum. So you go ahead and do the v2 prime, which would equal to just 216 minus 24s. You plug 18 into here, you have 216 minus 24 times 18. 24 times 18 is 432. You have 216 minus 432 equals to a number, which is, I mean, you can just say that it's less than 0. Since it's less than 0, you know that when x equals 18 in the original equation, that will give you the maximum. So you plug, I mean, where they put s? It's not x, it's s. So you have 4s plus h equals to 108. You do 4 times 18 plus h equals to 108. So 108 minus 4 times 18, h equals to 36. So the height is 36 and each of the sides is 18. If you want to find the maximum, I mean, I guess that would be it, since you're finding the dimensions. So the height would be 36 and each of the sides would be 18. If we wanted to find the volume, we would just do s squared times h. In this case, that would be 18 squared plus or times 36, and that would give you a volume of 11,664. Yeah, that's it.